Flat glass has been used in construction for centuries as a filling material for building openings. In modern architecture, the importance of a glass is growing as the emphasis is placed on the transparency and lightness of the constructions. Due to new technologies in production of glass and improving mechanical properties, there is a significant expansion of the applicability of glass to structural elements such as railings, stairs, glass beams, or even columns and load-bearing walls, as can be seen in the photos. In addition to their own weight, these load-bearing glass elements are also able to transfer snow, wind, and imposed loads. However, the design of such structures must be safe, taking into account the collapse consequences on both property and human life. Therefore, regulations have been put in place that define material properties and manufacturing, standardized procedures for experimental verification, and regulate the design of building structures. From the national standards used until the beginning of the 21st century, the European Union has moved to the Eurocodes, which ensure the unification of general rules for manufacturing, testing, design, and assessment in the field of building structures. The aim is to ensure the same quality and safety in Europe in the field of civil engineering. The Eurocodes provide general design criteria and methods that meet the prescribed basic requirements in terms of durability and reliability. They also provide general guidance for designers, operators, owners, contractors, and manufacturers of structural products. In addition, these standards allow to exchange and cooperation with EU countries. However, national standards are also used within the European Union in cases where Eurocodes have not been issued or have not addressed national conventions. There exist American, Australian, and other standards outside the EU. Harmonized European standards are currently used within the European Union. These standards establish the same rules in all European countries, allowing for a free market for goods, projects, flexibility, and the same standard of products and goods or design. Standards related to the glass building structures can be divided into several groups. The first group of standards is focused on glass production. These include, for example, material properties, production tolerances, size, thickness, initial imperfection, and so on, rules for refining soda lime silica glass by heat or chemical treatment, and rules for the production of laminated glass panes. This group also includes production standards for glass elements that are used in construction industry, such as U-profiles, glass hollow blocks, glass bricks, and so on. The second group of standards deals with the material properties of glass and the method of their determination. Various tests are used for this purpose, such as the coaxial double ring test, 4-point bending, according to EN 1288. By evaluating the experiment, the tensile strength of the glass under the bending and the Young's modulus can be determined. EN 16612 can be used for design of infill panels that can be classified in a glass consequences less than CC1. This includes window glass or insulated glass units made from monolithic or laminated glass pane simply supported along the edges and uniformly loaded perpendicular to the surface. At present, number of national standards, for example German, Italian, Dutch, can be used for the design of structural elements. The European standard for the design of load-bearing glass structures is under preparation. It will be available with the new revised generation of European standards under the designation EN 19100 and will be intended for the design of structural elements of glass consequences CC1 and higher. It's necessary to experimentally verify the impact resistance of the glass elements exposed to human body failing according to the EN 12600 standard to ensure safety of the users. This is important whenever the users could be injured by falling from a height, as in case of glass railings and windows with railing function. The principle of the test is very simple. Glass pane is subjected to the impact of pendulum with the weight of 50 kilograms, which simulates the human body. The impact is repeated with increasing pendulum drop height, and the failure mode is monitored. The glass panes are sorted to corresponding safety class according to the test results. However, glass can collapse not only from the influence of the human body impact, but also from a manual attack such as burglary. The resistance of flat glass pane against manual burglary is tested according to EN 3560 standard in two ways. According to the first method, the resistance of laminated glass to the impact of a steel ball with the weight of 4.1 kg from increasing height is determined. According to the second method, the glass pane is tested with hedged, where the number of the hedged hits determines the resistance. The last group of standards is focused on the resistance of glass to firearms or explosions. Laminated glass panes are tested for various types of weapons like military, hunting, hand weapons, caliber, mass, distance of shooting, speed or number of impacts. The explosion-resistant glass panes are classified according to the resistance to maximum pressure of the reflected wave. The above standards provide the necessary rules for structural glass elements to meet the reliability and safety requirements of building structures. The manufacturing, design, or composition of glass panes used in structures must meet the limits, tolerances, material characteristics specified in the standards to be used without problems throughout their service life.